Before we start our tutorial video today, if you love our videos, please click on like button and make sure to click on subscribe and bell icon to receive notifications of future helpful content of automation and process control. Now let's get started. What is an explosion? An explosion is any uncontrolled combustion wave. In order to create an explosion, there has to be fuel, for example an explosive gas such as hydrogen, an oxidizer, such as the oxygen in air, and a source of ignition energy, for example, a hot surface or an electrical spark. These three items are commonly referred to as the fire triangle and represented as below. In addition to this, two additional facets are required, something to mix the fuel and the oxidizer, such as the turbulence created in a gas leak under pressure, and containment. It is however common industrial practice to use the term explosion for both confined and unconfined combustion. This table indicates the hazardous area classification. As we can see, Zone 0 is an area in which an explosive atmosphere is continuously present or for long periods or frequently. Zone 1 is an area in which an explosive atmosphere is likely to occur in normal operation occasionally. Zone 2 is an area in which an explosive atmosphere is not likely to occur in normal operation, and if it occurs it will exist only for a short time. Also, this table indicates the ATEX categories and applications as the following. Therefore, we must be careful when choosing sensors and transmitters, especially that will be installed in hazardous area. As we can see here, on left side of pressure transmitter we have the following rating plate. On the rating plate we can notice that this transmitter has been selected to be installed in hazardous area. Now let's go into details of hazardous area characteristics and what is the meaning of each symbol. E is explosion protection. EX is European certification. I is the type of protection. I stands for intrinsic safety. Intrinsic safety can be one of several levels, A, B, or C. IA means the product has been assessed for installation in Zone 0. IB is for Zone 1. And IC is for Zone 2. There are 9 possible protection techniques, so let's review the other 8. D stands for flame-proof. DP products may be used in Zone 1. And DC in Zone 2. E is for increased safety. With an EB marking means it is assessed for Zone 1. The EC marking is for Zone 2. Another protection technique is represented by the letter P, which means purging and pressurization. PXB is for Zone 1. PYB also for Zone 1. And PCZ will be for Zone 2. Purged equipment cannot be assessed for Zone 0. NA is known as non-sparking. NC is known as sealing. And NR refers to a restricted breathing enclosure. M means that encapsulation is used as the protection technique. There are MA for Zone 0, MB for Zone 1, and MC for Zone 2. Q is for power-filled equipment and allows a product to be installed in Zone 1. O means oil-immersed equipment. OB is for Zone 1. And OC for Zone 2. Last one is the protection technique for gases known as OP, which is used for equipment having optical radiation. There are OPIS for Zone 0, 1, and 2. There are OPPR for Zone 1 and 2. And OPSH for Zone 0, 1 and 2. Gases in the IECX scheme are all in Group 2, further defined as 2C, 2B or 2A. Group 2C in the IEC scheme is the most ignitable. One gas has been chosen as the representative for each group. Acetylene is the representative gas for group 2C. For example, note that there is a group, 2B plus H2 in our table. This group specifically refers to hydrogen. The next part of the marking refers to the temperature class of the device. Temperature class refers to the maximum temperature the electrical apparatus might attain. Under normal operation or fault conditions, depending the protection technique used, there are 6 temperature classes: T6, T5, T4, T3, T2, and T1. This information is critical because given high temperatures, electrical devices can become a source of ignition. It would be catastrophic if a device with a T code of T1 were installed where there are gases that can ignite when temperatures reach 300 degrees Celsius, for example. The final part of the marking adds detail to the level of protection EPL. The assigned EPL indicates the likelihood that the equipment can become a source of ignition. The EPL of gases is always shown as G, EPL of dusts are shown as D, and of mines is shown as M. The example indicates G, meaning that gases are involved, because zones by definition indicate the nature of the hazard. There is a correlation between the zone and the EPL. An EPL of GA refers to zone 0, GP dictates that the product must be installed in zone 1, and GC is for zone 2. Finally, I hope with this tutorial video you will be able to identify the classification of the hazardous areas. Thank you so much for watching and have a nice day.